Welcome to Lecture 7, Chapter 1. Today we're going to look at some of the results coming from the Deep Decarbonization Pathways project we kept talking about, the DDPP. This is an important step forward in this course because it means that for the first time we're going to discuss in detail the country-specific ways in which countries can transition to a low-carbon economy, deeply reduce their emissions, but also continue to grow their economy and ultimately achieve sustainable development. So far, we've looked at the results of a global mitigation scenario, and we have calculated by how much the emissions from each sector, the emissions from power supply, from industry, from transports and buildings must decrease to stay within the 2-degree limit. We've also described the 3 pillars of the deep decarbonization of energy systems, the energy efficiency, the low carbon electricity, and fuel switching, which we said represent the foundations to design successful deep decarbonization strategies. And finally, we have identified the key technological challenges that must be met through directed and accelerated technical change to meet the global challenge of deep decarbonization. But a key question remains. How can these general principles, how can these high-level strategies be applied to particular country with vastly different national circumstances? Today we're going to see what specific solutions are available to individual countries, taking into account their different national circumstances. We're going to take into account their different socioeconomic contexts, their different aspirations and model of development going forward, but also their different natural resources endowments. And we're going to see how these country-specific solutions can be implemented. Defining country-specific solutions to deep decarbonization is really essential because if the world collectively is to meet the challenge of climate change mitigation, then every country, but in particular all the large emitting countries, need to have a good strategy to achieve both their economic objective, growth, development, but also the global goal of deep emission reductions, consistent and in line with the 2-degree limit. To do so, countries need what we're going to call in the rest of the lecture deep decarbonization pathways, or DDPs. What is this? Well, it's a roadmap or a blueprint, if you want, for each country to map out how they can transition to a low-carbon economy in line with the 2-degree limit. So why is it so important that countries develop these deep decarbonization pathways? Well, it's for a number of pretty simple reasons, although, to be frank, they've not been fully grasped by many. But it is our hope that as a result of the Deep Decarbonization Pathways project, each country will soon have one, and that the global agreement to be reached in Paris at COP21 in 2015 will encourage countries to produce one. But we're going to discuss that in further detail in the last chapter of this lecture. Countries need deep decarbonization pathways to mid-century, to the year 2050, because the nature and the scale of the global warming problem are such that there is unfortunately no quick or no easy fix to it. Deep decarbonization will not happen overnight. As we've seen, the ultimate objective is the phasing out of the freely emitting fossil fuels, but that's not going to happen tomorrow. It will only happen as a result of our sustained efforts during the second half of the century. So that's a pretty long time scale. And there is also no silver bullet to the challenge of deep decarbonization. There are many critical technologies, and we've been discussing in detail some of them. Solar photovoltaic, for example, wind power, nuclear for some country, carbon capture and sequestration if it becomes available, electric vehicles for sure, a bit everywhere. But none of them is sufficient alone to deliver the necessary emission reduction. So they need to be combined all together. Deep decarbonization is not about incremental change or small deviation from business as usual. And if we don't design even the rather short-term climate change mitigation strategies with the view of achieving a long-term objective that is consistent with the 2-degree limit, then we really run the risk of being misled. Because we could lock in some high carbon infrastructures that could prevent us from reaching that long-term goal in the future. Let me simply pick one example to make this point very clear. Shifting from coal to gas, as the United States is currently doing through shale gas and fracking, delivers some significant short-term emission reductions because gas is a lower carbon source of energy than coal. But it is still a pretty high carbon source of energy, at least compared to renewable energies or nuclear. So a power mix that would be primarily made of gas would emit way too much CO2 compared to the objective of deep decarbonization in line with the 2-degree limit. So the shift from coal to gas can, in a way, only be a matter of buying time, a bridging option, if you want, towards a truly decarbonized energy system. The deep decarbonization pathways we're talking about therefore need to backcast from the global goal of limiting the temperature increase below 2 degrees Celsius. They need to explore the transformations that are required to reach this goal. What do I mean by backcasting? Well, it's a term I use to describe a process where a target is set for the future, and then the changes needed to achieve that target are determined through the process of backcasting. It's very important that you don't confuse backcasting with rigid central planning, because a process of deep decarbonization must be very adaptive. These deep decarbonization pathways will have to be continually revised and updated based on new results from climate science, new technological innovation along the way, and also the lessons learned from the early implementation phases of these pathways. But it is really essential that countries explore the changes to their growth models, to their development frameworks, and in particular to their energy systems to reach the global goal of staying below 2 degrees Celsius of global warming. There are also less technical, more process-related, in a way, reasons why deep decarbonization pathways are so important. They're important because they're an essential tool for promoting a national dialogue on climate change mitigation options, to launch what is really necessary, a process of intense and complex problem solving. They're really a critical instrument to enable a public but also a policy discussion in every country on how best to achieve these emission reduction objectives, how to understand the possible trade-offs in between multiple objectives, but also to identify the synergies, the win-win solutions. The discussion over these deep decarbonization pathways should involve all the relevant stakeholders, the policymakers, the business, the civil society, all the different types of expert communities with some knowledge on the issue, the climatologists, the engineers, the geologists, the economists, the other social scientists. They should all debate very intensively the best options for deep decarbonization, identify the bottlenecks, and propose new approaches. In fact, you should try to develop a deep decarbonization pathway for your own country. Look at the pathways that were produced in the context of the Deep Decarbonization Pathways project, or at other studies if, unfortunately, your country was not part of the first phase of the project. Try to come up with different, possibly even better solutions. Discuss them with your professors, other experts, NGOs, business people, even your politicians if you have access to them. Send your proposals to us. I can promise that it will not only be a very interesting assignment, but something very useful to do.